theta. This is 2t d theta m by pi d theta omega square r. 2t d theta m by pi d theta omega square r. So this is your d theta. This is d theta. That two cancels. T equals to so T equals to m. T equals to m omega square r by 2 pi. T equals to m omega square r. T equals to m omega square r. T equals to m omega square r by 2 pi. T is equal to m omega square r by 2 pi. This is the tension in a rotating ring. You understood this point? Nilabja, have you understood this?
হ্যাঁ স্যার, মোটামুটি বুঝেছি।
ঠিক আছে. So basically what I'm trying to say is that what I have discussed here, if you have a ring and which is rotating with omega, then if you take any point here which is of mass dm, that will be feeling a force dm omega square r outside. At the same time, dm omega square r outside. At the same time, what is happening is if you have tension, I mean that dm omega square r will be balanced by the tension, and this tension ka d theta is here t cos d theta. Here it is t cos d theta, but then niche you have t sin d theta. That 2t sin d theta is equals to dm omega square r. So 2t d theta equals to dm omega square r. So 2t equals to m by pi omega square r. So t equals to what? M omega square r by 2 pi. M omega square r by 2 pi. T equals to m omega square r by 2 pi. Okay, no issue. So this we have already discussed. I mean, this is the case. Now let me to proceed with another thing. Gotcha, enough. So this is let's say the main thing. So far, let's not spend much time. Vertical circle we have already done. Banking we have also discussed. So vertical circle, banking, and then some other problems is also done. There are some others, but anyway, let's move in. So vectors,
স্যার ডে 12।
death well, na? Wait. Okay. So basically, you have death well. Correct. Death well, the
স্যার এখন না পেলে পরের দিনে করিয়ে দিতে পারেন, আমি মনে করিয়ে দেবো।
না ডেথ ওয়েলটা যখন বলেছি চল করে নি, ঠিক আছে চল। So basically what happens is you have a bowl kind of a thing like this. And এখান থেকে suppose you have a particle of mass m which is r. This distance is theta, I mean angle is theta, and let's say is rotating with omega. So suppose I have a ball and it is rotating with omega. So the ball is rotating with omega. Okay. The ball is rotating with omega. So a particle of mass m is moving with this ball. You have a particle of mass m which is also moving with this ball, and the particle is at rest with respect to ball. So so the thing is that the particle which you have here, particle of mass m, hmm, particle of mass m is moving with this bowl. Particle of mass m is moving with this bowl, and then the particle is and also the particle is at rest with respect to bowl, and also the particle is at rest with respect to bowl. You have a bowl. Within that bowl, you have a mass m, and let's say you have a particle of mass m in moving with this bowl, and also particle is at rest with respect to bowl. Okay. Let's say the bowl, this is frictionless, and we are also considering this to be frictionless. You have a bowl and the bowl is moving, and at a distance, the bowl have a mass m, and this connection is r at an angle theta. Particle of mass m is moving with this bowl, and also the particle is at rest with respect to the bowl. Question is, you have to find out the relation between omega, r, and theta. Let's first consider. Then let me to do this. Let's first consider the centrifugal force. Let's say you have this, which is of mass m. Along this direction, you have centrifugal force. This is r, this is theta, and let's say this is r. Hmm. So basically, what happens is the particle m. This is the circle, this is the circle on which particle is moving. This is the circle on which the particle is moving. You have mass m, which is have a centrifugal force outside, and along this direction is this. The friction coefficient is 0. This is r. This is r. This is r theta, and centrifugal force. Friction coefficient is 0. This is the circle on which particle is moving. Hmm. Because of which, what happened is you have a particle like this. This is mg downwards, and along this direction you have m omega square r cos theta, m omega square, m omega square sin theta. Let's m omega square r sin theta, and along this direction you have this normal. This is working n. So this is theta. This is mg, and why? If you consider this triangle, what do you see? Uh, you see sine theta is equals to perpendicular upon hypotenuse. So r equals to r sine theta. So this is basically m omega square r. So m omega square r sine theta. Therefore, n cos theta equals to mg. Therefore, n sine theta is equals to m omega square r sine theta. N cos theta is equal to mg, and this is n sine theta is equal to m omega square r sine theta. Therefore, what do you have? You have cos theta equals to mg by n, which is basically your mg by n means what? Uh, huh, mg by normal. So cos theta is equal to mg by n. ठीक है. अच्छा, we will calculate this. Wait. So you have the centrifugal force, and then what happens is the normal is along this direction. Huh. N cos theta is equals to mg niche, and n sin theta is equal to m omega square r sin theta. Huh. So that is what I was saying. N equals to m omega square r. N is equals to m omega square r. And also cos theta is equal to mg by n. Therefore, therefore what happens is cos theta equals to mg by m omega square r. अरे राजश्री, हाँ, हेलो राजश्री.
Good afternoon, sir.
Good afternoon. Omega square r. Cos theta is equal to omega square. Therefore, omega square is equals to g by r cos theta. So omega is equals to our g by r cos theta. That is the case. So the problem is I have a bowl, and within that bowl I have a mass m. So I have a bowl. Within that bowl I have a mass m, and that mass m is rotating. All the whole thing is rotating with omega, and this mass is at rest with respect to the bowl. The mass is at rest with respect to the bowl. This is the, and the surface is frictionless, and because of which what is happening, the mass m is rotating. The mass m is rotating on the bowl. So basically what is happening is you have m, and along this direction you have n. The mg is downwards, m omega square sin theta is along this direction. So your sin theta is equals to, and whatever you have found out, you have eventually found out that the angle, or let's say the angular velocity, is basically supposed to be square root of g by r cos theta. Angular velocity will be, angular velocity is supposed to be, angular velocity is supposed to be, angular velocity is supposed to be omega, which is square root of g by r cos theta. Square root of g by r cos theta. You understood this, Nilabju?
Excuse me, sir.
হ্যাঁ, রাজেশ বলো.
Yes, sir.
থেকে শুরু হয়েছে একটু বলবেন একটু উপরে।
আমি 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 কুইকলি সাম আপ করে দিচ্ছি, একটু দাঁড়াও. Okay, so we have already just finished, and we are supposed to move in the next. But before I submit progress, let me just quickly do. So আগের দিন we have solved, or we have discussed vectors. We have discussed and solved quite a few problems of kinematics, and NLM also we have done up to a certain extent, if not the full. I mean, up to a certain extent. And then we are discussing about circular motion. This is the main thing that we have discussed today so far. Circular motion এর কিছুটা পার্ট আমি করে ফেলেছিলাম আগেই, আর কিছুটা পার্ট আমরা আজকে করলাম. We have started from banking registry. Why do you need banking? Let's say, and what is the velocity square root of rg tan theta and all those things. Then after banking we have solved, let's say this, we have just solved currently death well. Let's see, if you have a bowl like this, and at a particle m is here, if it is rotating, And if it is rest at rest with respect to the bowl, and if it is at rest with respect to the bowl, then how will it look like? That is also the case. Acha. Then there is another thing. Then there is another thing. So this is the case. ठीक है. And we have also discussed. We have also solved some problem. For example, if you have a disk, and within that disk, if you have a mass m, and if that mass m is moving here and there within the groove, then there is a particular point, like you have to find out the time when the mass m moves out of the groove, and also you have to find out like the velocity when it comes out. These things you have to find out. This we have discussed, and we also discussed like this tension in a rotating string. So if your string is rotating, then what will be the tension? So we have found out m omega square by r. So these are the main thing we have discussed. If you just look into the notes, you will be able to understand everything. So I'll be sharing this note in the group. So after the class, whatever you have, we have discussed over in the last 1 hour 30 minutes, 1 hour 10 to 15 minutes. You will be able to easily understand. Okay, Rajesh?
Yes, sir.
Okay, sure. Okay,
মানে
now.
till death bellটা last হয়েছে.
Ha. Okay, so now we'll start a new thing. What we'll start? We'll start this thing is called work power energy. So circular we have already done, and after circular we are supposed to discuss, let's say, work power energy. So we will be now discussing about, let's say, work power energy.
So can you
What?
just scroll up? I can just take the screenshots.
Sure. I'll also be sharing this, but anyway.
Oh, you will share this, so then okay, you can
No,
continue.
you don't need to. I'll share the note.
Okay, sir. Okay, sir.
Work power energy. Say work power and energy. Okay. So basically, what happens is the definition is, which is we all know. Suppose if you have a mass m, and if the force is F, and if the mass is moving along this direction, let's say by a distance ds, then dw equals to F dot ds. dw equals to F dot ds. ठीक है. Or F ds cos theta. बाकी तो it's all good. We all know. So that's not the thing. अच्छा, এখানে যেটা জানতে হবে সেটা হচ্ছে কনজারভেটিভ, মানে ডিসকাস করতে হবে কনজারভেটিভ and non conservative force. Conservative and non-conservative force. So when it comes to conservative force, what does that mean? Conservative force means you have two kind of forces. One is conservative and another is non-conservative force. Conservative are the force for which the work done by the force doesn't depend on the path. Non-conservative are the force for which the work done depends on the path. And when it comes to conservative force, there are different kind of a force which are responsible. I mean, we can discuss this. For example, you have constant forces which are conservative. You can have force like this: fx I cap, fy j cap, plus fz k cap. We can have like this perfect differential When it comes to conservative force, these forces can be we can have these constant forces, we can have this fx I cap, fy z cap, and fz k cap forces, and also we can have like perfect differential, this kind of forces. So just to check, I mean, just to discuss quickly, if I say there is no point of doing all those things, I mean, আরে यार কি হচ্ছে বলতো এটা? আচ্ছা, I have to pay something, right, or something, I don't know. So if I have f equals to 2 I cap plus 3 j cap plus 2 k cap, I have the force this, and I have a here which is 1 comma 2 comma 1, and I have b here which is 3 comma 4 comma 3. Now if you have ab, you have to find out the work done, which is f dot ds. Find out the total work done. Find the total work done in moving a particle from a to b, and the mass is m. If you have the force F, then it is 2 I cap plus 3 j cap plus 2 k cap. If you have the force F, then it is 2 I cap plus 3 j cap plus 2 k cap, and you have a mass m. And then if you want to move the particle from A to B, from 1 to 1 to 3 4 3, you have to find out the total work done. You understood this point?
Yes, sir.
What is the total work done?
So this is the force and this is the displacement. You have So-
you're basically discussing the particle between A to B. 1 to 1.
নয় ডিস্টেন্সের ফোর্সে কম্পোনেন্টটা নিয়ে জাস্ট প্রয়োগ করে দিতে হবে বা ফোর্সে ওই কম্পোনেন্টটা
No, I mean, come on. You will just need to find out F dot ds.
হ্যাঁ
What is your dr here? Your
we
dr
have
is
to find
basically
the vector,
Yes.
means 3 minus 1 2 I cap plus 2 j cap plus 2 k cap, and then we will just dot product it with the
just do the dot product F dot dr.
4 plus 6 plus 4
Yes.
16 14.
So total equals to
14 joules.
1 2 3 2 dx plus 2 2 4 3 dy 1 2 3 2 dz. Four plus 6 plus 4. 4 joule. Understood? Anna? Okay. So this is a constant force. And now let's say I'll be doing this. Area under the curve. If you have a fx curve, if you have fx curve, then area under the curve is your total work done. Area under the curve is your total work. dw equals to f of x dx. dw is equal to f of x dx. ठीक है? And area under the curve is basically total work. ठीक है? So just on a quickly, just let's solve this, which is very easy. You just go like this. This is 10 Newton, this is 2 meter, this is 4 meter. Then find out the total work done.
joules.
Yes. So total work done equals to 10 into 2 plus half base into height. 20 plus 10 equals to 30. I mean 30 joules. Sorry. Okay. Now, okay, let's not spend more time here. Let me directly take you to this. Acha, if I have a force given to you as 2xy I cap plus x square j cap, 2xy I cap, f is equal to 2xy I cap plus x square j cap, and you are moving from A to B, which is 2 comma 4, and this is 0 comma 0. Find out total work done.
So x আর y এখানে ইয়ে ভেরিয়েবল তো
Yes, x and y is variable. F is equal to 2xy I cap. F is equal to 2xy I cap plus x square j cap. And you are moving from A to B. A is your 0, 0, B is your 2, comma 4. Your total work done is, find out the total work done. Achha, just solve one coming. Huh?
স্যার
Hmm.
এক্স স্কোয়ার ওয়াই সামথিং এরকম কিছু একটা আসছে
এবার তোকে তো ইন্টিগ্রেট করতে হবে। আচ্ছা, এদিকে দেখো।
0 to
You-
60 ইন্টিগ্রেট করতে হবে।
No, you basically have to do f dot dr. F dot dr, ठीक है? What is f dot dr? F equals to your 2xy I cap, x square j cap, and dr is equal to what? Your 2 I cap plus 4 j cap. uh, 4xy, sorry, না ঠিকই তো আছে, সরি এইখানে একটু গড়বড় হলো, সরি। এইটা আমি আপাতত dx dy লিখি, পরে লিখছি, সরি। হ্যাঁ, dx I cap dy j cap 2xy dx, sorry, 2xy dx, 2xy dx plus x square dy. So your total work done equals to, you have 2xy dx plus x square dy. Now, Rashi, how will you integrate this?
We
2xy
use
d.
the concept of differential equation.
Yes, this is basically a perfect differential. This is basically a perfect.
তাহলে ওটা হয়ে যাবে ইন্টিগ্রেশন ডি অফ এক্স স্কয়ার ওয়াই।
Yes, this is your perfect differential. And what do you mean by perfect differential? Uh, okay, so basically you have dx square y. If you have dx square y, then this is basically your x square dy plus 2xy dx. ठीक है? Then what do? Total work done equals to d of x square y, and then k equals to x square y. So what is your, at 0 it is 0, and this is 2 comma 4. 2 is 4, 4, 16. 0 to 16, so it is 16 only. 16.
ওটাই 0 to 16 ইন্টিগ্রেট করতে।
Correct. But if I give you a force something like this, F equals to 2y I cap, F equals to 2y I cap, then let's say at A it is 0 comma 0, at B it is 2 comma 4. Can you integrate it now? Like, can you find out the total work done? Can you find out the total work done? In this case, the answer is no. Here the work done is path dependent.
স্যার রিজনটা কেন একটু বলুন?
You see, you cannot. This is I cap. So what is F dot dr? F dot dr is 2y dx. F dot dr is 2y dx. So here you cannot integrate this, no? How will you integrate 2y dx? How will you integrate 2y dx? The question is, this y, how can you integrate? The variable is x and you cannot integrate y. So the thing here is, so the thing here is, this is path dependent. This is path dependent. So here the word done is, what do you say, path dependent. So here the word done is path dependent. That's why this is non-conservative. Anyway, I also discussed these things earlier in class 11 also, that if you have a curl 0, curl of a any force is 0, then we say this is a conservative force, and this basically implies I cap, j cap, k cap, del x, del y, del z, f of x, f of y, f of z equals to 0. Therefore, Therefore, if you have I cap, J cap, K cap, and del del X, del Y, del Z, Fx, Fy, Fz. If you have this, then I cap, if you have I cap del Fz by del Y minus del Fy by del Z, I cap del Fz by minus del Fy by del Z, del Fz by del Fx, del Fz by del X, del F of X by del Z, del F of Y by del X minus del F of X by del Y. And this is equals to 0, right? That means del Fz by del Y equals to del Fy by del Z. And this is del Fz by del X equals to del Fx by del Z. And this is del F of Y del X equals to del F of X del Y. If these conditions are satisfied, then only I will be able to say the force is conservative. For example, if I consider again this force where F equals to 2xy I cap plus x square j cap, then what is del fz del y? You don't have del fz, so this is 0. Don't have z, so this is 0. So that part is sorted. Come to this del fz, again you don't have this, so this is 0. You don't have you don't have z component. However, you have del fy by del x. Del fy by del x is what? 2x. Is it equals to del fx by del y? Del fx by del y is also 2x. Yes. So these conditions are satisfied. You understood this point? So basically, this is a thing. And what we understood is that what we understood is that what we understood is that when it comes to potential energy, in case of conservative forces, in case of conservative forces, we can always define potential energy. We can always define potential energy. In case of conservative forces, we can always define potential energy. In case of conservative forces, we can always define potential energy. So basically, what happens if you have a particle here at A and if you have a particle here at B, and if you're taking the particle from A to B, A to B, or A to B, in whichever direction you are taking them, doesn't matter. The work done between A to B is path independent. The path from A to B and the while you're taking the object from A to B, the work done is path independent. Okay. 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 So let proceed with this problem. Let me just to just for the sake of completeness. So if I have ring, and this is M. This is R. This is d theta. And this is theta. The length is pi r by 2. And this is your reference level, which is equals to 0. Find out the total potential. You have a ring. You have a ring of mass m. You have a ring of mass m. You have a ring of mass m, and the length is pi r by 2. You have a ring of mass m. The length is
স্যার কোশ্চেনটা আরেকবার বোঝাবেন এটা?
you have a ring of mass m. I mean, you have a ring. This is your ring. The mass is m. The radius is this, like this. So the length of the ring is pi r by 2. This is your reference level. The question is, what is your total potential energy of this ring? Find out the total potential energy of the ring. Find out the
না মানে এটা রিংটা কিভাবে বোঝানো হচ্ছে বুঝতে পারছি না।
আধা রিং না, শুধুমাত্র রিংটা শুধুমাত্র ওয়ান কোয়াড্রেন্টে আছে এবং ইট ইজ ওরিয়েন্টেড দ্য ওয়ে ইট ইজ শোন, লাইক ইন আ সার্কুলার ওয়ে। বুঝলি?
Means what the why have you drawn those small circles over
Oh,
there?
acha, sorry. Ring means I should be saying chain actually. Sorry. This is actually chain. So I was using the wrong word. Let's say I'm saying chain, which is just like this, at a distance r, ठीक है? And the mass of the chain is m. You have to find out the total potential.
Means it is resting on something or it is just like that?
Yeah, I mean it is oriented like this. The ring is oriented like this. The mass is m. The radius is r.
স্যার স্মল আর এর ক্যাপিটাল আর কি আলাদা? ওইখানে যে স্মল আর নিয়েছেন নাকি ওটাও আরই, মানে থ্রু আউট সেম রেডিয়াস?
ওটা ছোট আর।
আচ্ছা আচ্ছা, ঠিক আছে
ওটাও ছোট আর ধরে নি।
ঠিক আছে,
ছোট
ঠিক
আর
আছে।
ধরে না, বড় আর ধরে না, যা ইচ্ছা বা ওটা ডিটেইলস।
হ্যাঁ মানে সেম কিনা ওটাই, ঠিক আছে।
হ্যাঁ।
স্যার 2m by pi?
কি 2m by pi?
ইউ
না
ইউ টোটাল?
না না না, 2m by pi gt কোথায় গেল?
ও হ্যাঁ, সরি স্যার।
Sir, 2 capital mg r by pi.
ইয়েস।
জি আর একটা অ্যাড হবে, আমি জি আরটা অ্যাড করিনি, আমি শুধু ইন্টিগ্রেট করে আনসার বলে দিয়েছি। 2m gr by pi।
ওকে,
কোন ল্যান্ডস্কেপে করলে স্ক্রিনটা বড় বড় দেখাচ্ছে, এরকম একবার করতে পারবে?
এভাবে করলে বড় দেখাচ্ছে?
হ্যাঁ হ্যাঁ, এটা এরকম ভাবে বড় দেখা, এটা ঠিক আছে।
ঠিক আছে। Basically what is happening, your du is আছে কোন একটা সময়ে এটাকে ধরে নে আর সাইন থিটা, and এই পোর্শনটা ধরে নে ডিএম, এই পোর্শনটা ধরে নে ডিএম। তো বেসিক্যালি হোয়াট ইউ নিড এম জি এইচ, সো ডিএম জি আর সাইন থিটা, ডিএম জি আর সাইন থিটা। So basically what du equals to, what is your dm, dm is equals to total mass m per unit length pi r to 2m by pi r d theta, 2m by pi d theta, 2m by pi d theta. So 2m by pi,
তো আপনি হাইটটাকে 8 sin থিটা তুলেছেন তো?
हाँ हाँ हाँ, 2m by pi, 2m by pi d theta, g r, हाँ আবার ছোট বড় লিখছি, g r sin theta. Two m by pi d theta, g r sin theta.
স্যার আরটা ক্যাপিটাল হবে না?
আমি ছোট আর নিয়ে কাজ করছি এখানে শুধু, হ্যাঁ মানে সরি এখানে বড় আর লিখে দিয়েছি, সেটা ভুল করেছি, সেটা ছোট আর লিখ।
হ্যাঁ ওটাই ওটাই।
হ্যাঁ হ্যাঁ, তার মানে বেসিক্যালি কি হলো, টু এম জি আর, টু এম জি আর বাই পাই, টু এম জি আর, টু এম জি আর, টু এম জি আর বাই পাই সাইন থিটা ডি থিটা, টু এম জি আর by pi sin theta d theta. So your u equals to integration of du equals to 2mgr by pi. Two mgr by pi 0 to pi by 2 sin theta d theta. You are integrating from 0 to pi by 2 sin theta d theta. So 2mgr by pi 2mgr by pi sin theta integration লিখে minus cos theta pi by 2 comma 0, 2mgr by pi minus cos pi by 2 plus 1. Two mgr by pi, u total equals to 2mgr by pi. ठीक है, ओके चलो ठीक है, now let's move on.
একটা কোশ্চেন ছিল,
हाँ
একটা কোশ্চেন ছিল
বল,
স্যার, l is equal to pi small r by 2 হবে না?
কোনটা l is equal to মানে,
এই যে লেন্থটা নিয়েছেন, আর্ক লেন্থটা
হ্যাঁ হ্যাঁ
ওটা স্মল আর হবে না? ডি স্মল, ওই পাই স্মল আর বাই 2, এটা
কোথায় ক্যাপিটাল করেছি,
ক্যাপিটাল আর, ও আচ্ছা ক্যাপিটাল আর আগে আগে লেখা ছিল, সরি।
হ্যাঁ আগে ছিল পরে ঠিক করেছি। Okay, so we'll be sitting, we'll be having the class till 6. After that, I have another work. So, anyway, so ठीक है, we still have 1 hour. Acha. Next, we will discuss about equilibriums, and in these equilibriums, we will basically be dealing with potential. And we already know that how to find the equilibriums like stable equilibrium, unstable equilibrium, and so on and so forth. These things we will mainly be discussing. So, basically, what we will discuss is so F net equals to 0. Let's say this is the F net equals to 0, this is unstable. This is F net equals to 0. Let's say this is stable. This is unstable, this is stable, and here let's say F net equals to 0. This is neutral. Okay.
So write it a neutral kind of.
This is saddle point kind of a thing.
Huh. So
Means it goes like this.
oh, अच्छा वही रेस्पेक्ट है ठीक है.
Yes. So F net equals to 0. So that is your neutral. So you have your this. Here it is unstable equilibrium, here it is stable equilibrium, and here it is neutral equilibrium. So F equals to 0. What does that mean? Minus du dx equals to 0. So when you are at you are at unstable equilibrium means what your second order derivative will be unstable means maximum value of function means it will be negative, and when you are at lowest point that means your second order derivative will be positive. Anyway, these are the very basic things which we all know. Now let's say we are proceeding with this. Let's say I'm giving you a sum. This u equals to 12x minus x cube plus y cube minus 3. U equals to 12x minus x cube plus y cube plus minus 3y. Then f equals to minus 12 minus 3x square I cap minus 3y square minus 3 j cap. F equals to minus 12. F is equal to minus 12 minus 3x square I cap minus 3y square minus 3 j cap. Find out the position of stable and unstable equilibrium. Find out the positions of stable and unstable equilibrium. Okay. সলভ করলি? নীলাব্জ, আর ইউ সলভিং?
Yes, sir. Start with. Sir, dou u by dou x আসবে minus 6x আর dou u by dou y আসবে 6y.
এরকমই কিছু একটা আসবে। প্রসিড, আমাকে পয়েন্টগুলো বল। ওকে, so basically what will happen is you have the potential as u is equal to 12x minus x cube plus y cube minus 3y, and that is where the force is given as minus 12 minus 3x square I cap plus minus 3y square minus 3j cap. So basically what will happen, your f of x equals to what? Du by dx, or minus du by dx. And that is what? 12 minus 3x square equals to 0. 12 is equal to 3x square. X square is equal to 4. X is equals to plus minus 2. F of y equals to minus du dy, and this is equals to 3y square minus 3 equals to 0. Y square is equal to 1. Y is equals to plus minus 1. So you have plus minus 2 and plus minus 1. Therefore, what you have is minus 2 1 2 1 minus 2 minus 1 2 minus 1. These 4 points you have. Two 1. If we move along x, when it comes to 2 comma 1, when it comes to 2 comma 1, what will happen? We move along x, so this is unstable equilibrium, and we also move along y, this is stable equilibrium. How do you know? So if you calculate the second order derivative, that is d square u by dx square, which is minus 6x, and if you do d square u by dy square, which is 6y. If you now put 2 comma 1, 2 if you put, it will be minus 12. Minus 12 means maximum value, means along x unstable. Along x unstable, and if it is y, then 1, so along y stable. Hmm. If it is minus 2 comma 1, so this is minus 2 comma 1 means this is 12, this is 1. Do not positive. Positive means minimum, means stable. If it is 2 comma 1, then it is minus 12, which is maximum, and it is minus 6 is maximum. Both the cases are unstable. Yes. Anyway, so these things we know. That's not no point of, let's not spend more time here. Later move on to this discussion of this work energy theorem. Work, uh, uh, work energy theorem. So what do you what do you mean by work energy? We know that the total work done by all the forces, total work done by all forces equals to
0.
I, total work done by all the forces zero करो, change in kinetic energy. Work done by all the forces equals to change in kinetic energy. Work done external plus work done conservative plus work done non-conservative plus work done pseudo equals to change in kinetic energy means kf minus k. So work done by all the forces equals to change in kinetic energy. Work done by all forces. Work done by all forces equals to change in kinetic energy. Work done by all forces. Work done by all forces equal to change in kinetic energy. Work done external. Work done conservative. Non-conservative pseudo equal to kf minus k. Okay. Now, when it comes to work done external, this is zero. If your work done external is zero, if your work done conservative is zero, if your work done non-conservative is zero, pseudo all is zero, then you have work done external is zero, work done non-conservative zero, then you will basically be having work done conservative. This is zero, and this is also zero. So work done conservative equals to change in kinetic energy. So kf minus ki. kf minus ki. ठीक है. Therefore, what do you know? What is work done by conservative force? It is actually change, minus of change in potential energy. Minus of change in potential energy means kf minus ki. So this is basically what uf minus ui. Kf minus ki. So uf plus ui. Kf minus ki. So ui plus ki equals to kf plus ui plus ki equals to kf plus ui plus ki. ui plus ki. ui plus ki is equal to kf plus kf. Okay. Okay. Acha. Next we will discuss this. Ha. Next we will discuss this. Let's this is mass m of 1 kg. The friction coefficient is 0.2. This angle is 37 degree. This is 2 meter. K equals to 50 Newton per meter. And at this surface, U equals to 0.5. You have 2 meter, this is 0.2, this is M, this is 37 degree, this is 2 meter. K is equal to 50 Newton per meter and mu is equal to 0.5. Find the you have to see, like find the compression in the string such that mass M kg comes to rest. Find the compression in the string such that mass M kg comes to rest. We have a mass M 1 kg. This is friction coefficient is 0.2, is 2 meter. Find the compression in the string such that mass M kg comes to rest. Solving. So the distance is 2 meter, the height is 2 meter, mass is 1 kg. Friction coefficient of the inclined plane is 0.2 and the friction coefficient of the surface is 0.5. Find the compression in the string such that mass M comes to rest. Rajesh, is solving? Ready? Hello, Nilabj, are you there?
Yes, sir.
Okay.
Actually,
মাস এমকেজিটা স্লাইড হয়ে পড়ে গিয়ে ওখানে ধাক্কা মারবে আর তখন ওটা ওখানে গিয়ে রেস্টে আসবে।
হ্যাঁ মানে রেস্টে আসবে বাই ডিউরিং দ্যাট টাইম ইট উইল অলসো কম্প্রেস ইট।
কম্প্রেস করার পরে এক্সপ্যান্ড করার চেষ্টা করবে না আবার?
কম্প্রেস করার পরে
ও আবার এক্সপ্যান্ড করার চেষ্টা করবে না স্প্রিংটা?
না, আমার জাস্ট ম্যাক্সিমাম কম্প্রেশনটা দরকার। ও পরে আবার এক্সপ্যান্ড করার চেষ্টা করবে সেটা কিনা সেটা পরে উইল সি। but it will be compressed, and during compression it will be the case. Fine. Does you sort?
স্যার হচ্ছে না।
আচ্ছা ঠিক আছে।
স্যার আমি করছি।
হ্যাঁ নিলাম, wait. So basically I will be using work energy theorem, ঠিক? So we'll be using work energy theorem. And how will you do? So using work energy theorem, this is for inclined plane and this is for horizontal plane till x. For inclined plane, plus for horizontal plane till x. For inclined plane, what is this? For inclined plane, this is mg, this is 37. So along this direction, mg cos 37. So along this direction, it is friction. So mu mg cos theta. So minus mu mg cos theta. And the displacement is what? This is, so sine 37 equals to perpendicular upon hypotenuse. So hypotenuse is what? 2 by sine 37. For horizontal plane, it is how much? Mu mg into 2 plus x equals to 0. You understood my point? 2 plus x. So mu mg cos theta. What is mu mg cos theta? Mu means 0.2. Minus 0.2 minus 0.2 into 8 into mg cos theta is 8 into 2. Sorry. 0.2 into 8 into 2 by sine 37. What is sine 37? 345. So 3 by 5. Minus again 0. Again mu mg. What is mu mg? এখানে mu mg হচ্ছে 0.5 into mg. Okay. mg cos 37. 37 cos 37 মানে 4 by 5. আর mg কত? আচ্ছা, m is equal to 1 মানে 10. তো 10 মানে 8. ঠিকই আছে, 8 লিখেছি। আচ্ছা, এইখানে কত ছিল 1 আর g কত ছিল 10। তাহলে 10 into 2 plus x equals to 0. Therefore, it is 0.4 into 8, 5 by 3 minus 5, 2 plus x is equal to 0. So this is basically your 3.2 by 3 minus 2 minus x is equal to 0. Minus, minus 3.2 minus 6 minus 3x is equal to 0. So this is 9.2 equals to 3x, x is equals to minus 9.2 by 3 or something. Something of this sort will be coming.
স্যার একদম ফার্স্ট লাইনে একটু বোঝাবে, মানে এনার্জি কনজারভেশন তুমি মানে কোনটার কি দিয়ে কি করলে?
Oh, sorry. Wait. Basically, wait. If you using work energy theorem, I have two planes. One is my inclined plane and one is my horizontal plane. আমাকে কি বের করতে হবে? Find the compression in the string such that mass comes to rest. Now, if I use my work energy theorem, ultimately the sorry, initially the mass was at rest. Finally, also the mass will be at rest. So change in kinetic energy is 0. So using work energy theorem, what will you get? For inclined plane plus for horizontal plane, if you do. For inclined plane, it is mg. The total work done is because of this gravitational work done, mgh. So the force is mu mg cos theta or cos 37, and the displacement is 2 by sine 37. Then you have horizontal. In horizontal, you have force is mu mg, and the displacement is 2 plus x. So basically, here I'm just finding out the work done by the frictional force. It is this.
আমি যদি সেম জিনিসটাকে মানে মেকানিক্স দিয়ে প্রসিড করি, সরি মেকানিক্স বলি, মানে কাইনেমেটিক্স দিয়ে।
Okay, হতেই পারে। তো you can, but if you can solve a particular problem relatively easier way, so why will you go? Anyway, so work done by frictional force is what? Work done by frictional force is minus mu mg cos 37 into 2 by sine 37, and এদিকে হচ্ছে mu mg into 2 plus x. So this is 0.282 and that is 3 by 5, and this is minus 0.5 10 2 plus x. Acha, so this is where I'm basically finding the work done by this your frictional force. 0.282 by 3 by 5 minus, huh. So this is basically what your, how will you calculate? 0.2 into 16 into 5 divided by 3. 0.2 into 16 divided 5 by 3 minus 5 into 2 plus x. So basically what will you do? 16 by 3 minus 10 minus 5x. This is the ordinary frictional force. So minus 16 by 3 minus 10 minus 5x equals to 0 plus 0 plus half into 50 into x square minus 0 minus 1 into 2 into 10. Solve it and find x. You understood this part? So, Nilabjo, Ashish,
হ্যাঁ স্যার আছি।
but, so this is the work done by frictional force minus 16 by 3 minus 10 minus 5x, and that should be equal to change in kinetic energy. And change in kinetic energy is basically what? Half 50 x square minus 1 to 10. So if you now solve this, you will be able to find out x. Okay, let's proceed with the next. If I have to go a bit fast then. अच्छा ठीक है चल এটা today this is the last problem for today. I have some अरे बाबा এই যে because of this the subscription টা নিতে হবে। So let's say I have a chain like this. I have a chain like this. This is a frictional coefficient. I have a ring like a mass. This is a frictional coefficient mu. Length equals to L. Mass equals to M. Question is find the minimum length required such that the change doesn't slip, so that it change remains equilibrium. Find the minimum length required. Find the minimum length required such that the chain does not slip. Find the minimum rate required such that the chain doesn't slip.
Sir, what is means there is no length given from the edge of the table to the down.
Acha, if you want, you can consider this to be x and this to be L.
So the full surface of the table is having a frictional coefficient of mu.
Yes.
So give some more time, sir. Wait.
Okay, okay, okay. Have you solved?
So 2 minutes. 2 minutes. 2 minutes.
Hmm. Okay. Anyway, so the weight of the portion which is hanging, let's say of x.
So that if we take mass per unit length, then the weight of the
Ha
hanging
ha ha
portion is
ha. Now,
mgx by L.
अच्छा
mgx.
ठीक देखिए हाँ weight of this portion x mass per unit length xg mu xg ठीक है this is has to be less than equals to
So why are we taking mu?
I mean I'm just saying this to be mu less than equals to mu m by L minus x into g. Therefore, m by L x g mu m by L minus x g. So your m by L will cancel.
Sir, x
Huh.
square by x minus mu, value of L.
দাঁড়া x g will cancel, x equals to x less than equals to mu into L minus x. So x less than equals to mu L minus mu x. X plus mu x less than equals to mu L. X less than equals to mu L by 1 plus x less than equals to mu L by 1 plus mu. Understood? X less than equals to mu L by 1 plus x less than equals to mu L by 1 plus mu. Then the length will be
We will take L minus x and then they will add.
L minus x. So this is L minus mu L by 1 plus mu. 1 plus mu. L plus mu L minus mu L. L by 1 plus mu. You understood this point?
So the first inequality, how have you written that?
In order to have this ring, chain, in order to have this chain in equilibrium, the weight of this portion should be less than the friction force here.
Yes, sir.
So this is mu mg is the weight of the lower portion, and it has to be less than the frictional force, which is mu this g. Acha, by the way, sorry, this is mu I have written. Na? I have done a mistake here. This is not, sorry. এখানে এটাকে m by l রেখে ফ্রিকশন, তাহলে আমাকে আমি এটাকে মিউ বলতে পারি, সরি, দ্যাট ইজ অলসো ট্রু, বাট তাহলে আমাকে ফ্রিকশন কোএফিশিয়েন্ট অন্য নিতে হবে। কেন কি ফ্রিকশন কোএফিশিয়েন্ট আর এটা দুটোই আমি মিউ নিয়ে নিতে গড়বড় হয়ে যাবে, সরি। এটাকে m by l xg রাখ, m by l xg রাখ, তাহলে এদিকে m by l xg লেস দেন ইকুয়ালস টু, কেউ আসলো নাকি? তাহলে এটা m by l xg, এটা m by l, এটা দিস m by l ক্যান্সেল, x less than equals to mu into L minus x. So x less than equal to mu L minus mu x. So x plus mu x less than equal to mu L. ঠিক আছে রাজশ্রী?
Yes, sir.
ওকে, আচ্ছা ঠিক আছে, চল, হ্যাঁ তাহলে আজকে এই থাক, উই উইল মেট এগেইন আফটার সাম টাইম, আই লেট ইউ নো। তো ঠিকই আছে তাহলে, ঠিক আছে, রাখলাম তাহলে, হ্যাঁ।
স্যার নেক্সট ক্লাস when sir?
নেক্সট ক্লাস নেক্সট ওয়েডনেসডে দেখি, আমি যদি তাহলে একটা হতে পারে ছোট ছোট ক্লাস রাখলাম, ধরে নে 2 ঘন্টা 3 ঘন্টা, তাহলে রোজ বৃহস্পতিবার করে উই ক্যান মেট। আর লম্বা ক্লাস হলে আই অলসো নিড সাম, আই হ্যাভ টু ডু সাম ওয়ার্ক অলসো, না বুধবারটাই ছুটি থাকে। তো
So, sir, next week you can take a small class just.
হ্যাঁ তাহলে ঠিক আছে, তাহলে এটা চলুক।
Yes sir, that's
হ্যাঁ
better.
তাহলে লেটস কিপ অন রিভাইজিং, অল্প অল্প করে একটা করে চ্যাপ্টার করতে থাকি, and উইল কভার ইট আপ, ঠিক আছে?
Okay, sir.
Okay sir, yes sir.
ওকে,
Okay. Thank you sir.
Thank you, sir. Good night, sir.
গুড নাইট।